I'm Mrs. Mochian. Today's video is about the scientific method. In this video, we'll discuss science and the scientific method in order to gain an understanding of how we can reliably and validly find answers to our questions. What is science? What can it do for me? Science is the method for answering our questions, and it's also the information gained from the investigation. It helps us understand our world and gain meaning from everything we do. It also helps us understand and put these meanings into the context of our lives. Science can be divided into separate areas of study, such as biology, the study of living things. That includes plants and animals. Physical science pretty much covers everything else. It's the study of non-living things like chemistry, physics, astronomy, and other areas. Science is a reliable way of investigating and discovering knowledge about the natural world. It's a process which allows a person to gain the highest degree of certainty. This method of investigation and justification is called the scientific method. We'll break down the scientific method into 7 basic steps. Step 1. Identify the problem and create a problem statement. It's measurable, it's quantifiable. It's a who, what, why, where, when, or even how question. The scientific method begins when you ask a measurable question about something that you've observed. This is an important step because every step afterwards will lead back to this question and provide you an answer to the question. For instance, how much food will I eat before I gain weight? Step 2. Form a hypothesis. A hypothesis is an educated guess based on some prior knowledge. A hypothesis helps to answer the original question by predicting an outcome and suggesting a method for determining the answer. For instance, if I eat an extra helping of food each day, then I'll put on weight because I'm not exercising enough to burn off the extra calories. It explains what I'm investigating, what I'm going to test, and what I expect the outcome to be. Step 3. Create an experiment. Your hypothesis already suggests what you'll test for and how you'll do it. Now you'll need to design a method to test a hypothesis. You must list all the materials you'll use for the investigation and write a detailed and numbered procedure that identifies your variables and lists the numbered directions that anyone can follow without any questions. Think of it as a recipe. When you're following a recipe, you need to know exactly what temperature to set the oven at, how long it's going to cook, how many eggs you're going to add to it, and so on. If any of those things are left questionable, then your cupcakes are not going to end up the way you want them to, or they'll end up different every time you make them because you're going to have to guess exactly what temperature the oven should be set at or how many eggs to add. So your procedure is the same way. In the picture shown, compare the two procedures. What's wrong with the one on the left-hand side? Why was the outcome unsuccessful? Sadly, no one could eat the sandwich on the left. It doesn't even look like a sandwich. The problem is the lack of detail. If you've never made a peanut butter and jelly sandwich, you're not going to have any idea what to do. You need detailed directions to follow. Details are the most important part of the experiment because without the detail, it would be nearly impossible for someone else to replicate your experiment. Step 4. Perform the experiment. This is where you actually conduct the procedure, making any changes that might need to be made in order to test your hypothesis. You'll record any observations, collect and organize the data in charts, and graph it. We mentioned variables before, but it's worth repeating here. Anytime you're testing something, there are variables. The thing that you're manipulating or changing is the independent variable, or the IV. The thing that you're measuring or that's being affected by the independent variable is the dependent variable. Remember, the IV affects the DV. A sample that's not being manipulated or exposed to any change is called a control variable or just a control. Step 5. Analyze the data. Once you've collected and organized the data, you'll need to analyze it. Numerical data will usually be graphed, and there's several different types of graphs I'd like to talk about now. A line graph is used to show change over time. Points are connected from the left to the right. In scatter plots, they show the correlation between variables. The data points are not connected, but a line is drawn that usually shows an equal amount of data above or below the line. It shows a pattern or a best fit line. A bar graph shows different groups or more than 2 groups of things being compared. The bars don't touch and represent the average of that data or the mean of the data. Histograms. Histograms show distributions of data or a comparison of data. They can look similar to bar graphs, but the bars don't touch. Pie charts. Pie charts show parts of the whole. Each segment shows a percentage of the 100%. To review graphing basics, I recommend this Bozeman Science video. Step 5. Analyze the data. Look at what your data is suggesting. What patterns or trends can you deduce from your graphs? Are there any changes that you would need to make to your experiment to get the data you need? Make sure you have evidence to support your findings. Step 6. Conclusion. After analyzing the data, you need to infer what the data is suggesting and write it up so that even if someone only read your conclusion, didn't see anything else about your experiment, they'd know exactly what you did and why you did it and what your findings were. Your conclusion should repeat your problem statement and your hypothesis and include enough data to support and explain your inference. And it needs to state whether or not your hypothesis was supported or not by the evidence. Step 7. Communicate your results. Let the world know what you found. Discovering the cure for cancer won't benefit anyone unless you communicate it to the world. In review, the 7 steps of the scientific method are identifying the problem, forming a hypothesis, creating an experiment, performing the experiment, analyzing the data, writing the conclusion, and sharing your results with the world. The scientific method is not just used in science class. It's used every time you have a question that you're looking to answer. It's used in history, it's used in math, in science, in English, in the kitchen. Anywhere that there are questions to be answered, you'll be using the scientific method, whether you realize it or not.